Hello students. So let's start with a new chapter, that is sequences and series. Okay. So let's start with sequence. What is a sequence? It is a collection of something, okay, which has some order. Okay, that is called a sequence. Now there are two types of sequences: finite sequences and infinite sequences. Finite sequences means there is a fixed number of terms in that. Okay. Terms means A1, A2, A3 and so on. Okay. And there are some sequences which are infinite. So infinite terms are there. Okay. Like for example, sequence of even natural numbers, that is infinite. Okay. So for even natural numbers, they start with 2, 4, 6, 8 and so on. Okay. So the nth term will be 2n. Okay. So this type of numbers, you can identify them. That is, this numbers we have seen in 10th standard, that is in arithmetic progression. Okay. AP. So whenever you have a sequence following a specific pattern, that is called a progression. Okay. So let's first sum up this. So okay, there is a sequence called Fibonacci sequence. Okay. Um, so an arrangement of numbers such as 1, 1, 2, 3, 5, 8, dot 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 has no visible pattern, but the sequence is generated by the recurrence relation given by, so A1 is equal to A2, okay, then A3 is equal to A1 plus A2, and an is equal to an minus 2 plus an minus 1, where n is greater than 2. Okay. A1 and A2 are fixed, and later on, that is from A3, we have to use this formula, an minus 2 plus an minus 1. Okay. This is Fibonacci sequence. Okay. Then there is, after sequence, we go for series. Series is you have to add all the numbers, okay, in a sequence. So suppose this is your sequence, then series is also finite infinite. So series is an addition, A1 plus A2 plus A3 and so on. Okay, and it is denoted by sigma. Okay, from 1 to n. This is a finite series, AK. Okay, so it starts from A1, A2 plus dot 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 an. Okay, so you have to add the numbers accordingly as they are given in sequence. Okay, this is a series. Then let's see some examples. Write the first three terms in each of the following sequences defined by the following. Okay, so there are some sequences which are given, and we have to write first three terms. So an is given as 2n plus 5. So you have to start from n equal to 1. Okay, so this becomes a1. In place of n, you have to put 1. So this is 2 plus 5, 7. Okay, for n equal to 2, a2, 4 plus 5, 9. Then n equal to 3, a3, 2 into 3 plus 5. So 6 plus 5, 11. Okay, so these are first three terms of this sequence. The next one which is given is an equal to n minus 3 upon 4. Okay. So start from 1. So a1 is 1 minus 3 upon 4, which is minus 2 by 4. So this is minus 1 by 2. N equal to 2, a2, 2 minus 3 upon 4, minus 1 by 4. Then n equal to 3, a3, 3 minus 3 upon 4, which is 0. Okay. Next example which is given is, what is the 20th term of the sequence defined by? So we have to find the 20th term. 20th term means n equal to 20 we have to put. Okay. And the sequence is given as an equal to n minus 1, 2 minus n, 3 plus n. So in place of n you have to put 20. Minus 1, 20, 20. Okay, so this is 19, 18, 23. Then you have to multiply it. So the answer will be negative. It comes to 7866. Okay. Next question is, let the sequence an be defined as follows. You have to find first 5 terms and write corresponding series. Okay. So first is you have to, it is defined as a1 equal to 1 and an is given as an minus 1 plus 2 for n greater than or equal to 2. Okay. So a1 is equal to 1. First term is given. Second term we have to find. For n greater than or equal to 2, you have to follow this formula. So n equal to 2, 2 minus 1. So this is 1, a1 plus 2. a1 is 1, 3. Okay. For n equal to 3, a3, 3 minus 1 plus 2. So a2 plus 2, a2 is 3, 3 plus 2 is 5. Then n equal to 4, a4, 4 minus 1 plus 2. So a3 plus 2, a3 is 5, 7. Okay, and next term will be 7 plus 2, which is 9. These are the 5 terms, and we have to find the sum of the first 5 terms. So, no, you have not sum, right? Corresponding series. Series only you have to write. Okay. So, series is 1 plus 3 plus 5 plus 7 plus 9 plus dot dot dot. This is the series. It is addition of the terms in the sequence. Okay. Next is arithmetic progression, which we have learned in 10th standard. Okay. AP. So a sequence A1, A2, A3 dot dot AN dot dot is called an arithmetic sequence or arithmetic progression if an plus 1 is equal to an plus d. Okay, where n belongs to set of natural numbers, is called a1 is called a first term and an is called a nth term, and the constant term d is called a common difference. Okay. So the terms in AP are given as a a plus d, a plus 2d, and so on. So the nth term, that is general term, is given by an equal to a plus n minus 1 into d. Okay. So arithmetic progression is a sequence of numbers where we have a finite common difference, that is common difference is same. Okay, so how we find common difference? D is a2 minus a1, that is second term minus the first term you have to do. That common difference should be same for all the terms. Okay, then only we can say that given sequence is an AP. Okay? And we can write AP if you have a first term and D. Okay, that is by this. Okay? And this is the general term which we are going to use. Okay, then we have Sn, which is the sum of n terms. Okay, An is the nth term and sum of n terms is given by Sn. N by 2, 2a plus n minus 1 into d. Okay. This is the first formula, and second formula is Sn equal to n by 2 a plus an. In place of this an, we also write it as L. Okay, you can use L also. An is same as L, which is the last term. Okay, so we are going to solve this problems. Okay, so the question which is given in the textbook, example 4, in an AP, if mth term is n and nth term is m, where m is not equal to n, find the pth term. Okay, so mth term means am is given. Am will be given as a plus m minus 1 into d equal to n is given, and nth term is given as a plus n minus 1 d equal to m. Okay, we have to find pth term. Okay. So m is not equal to n. Pth term is given as ap a plus p minus 1 into d. Using this two, you have to find d. Okay. So if I take this two, what it will be? I'll write this later. So if I subtract this, so I'll get this a and a get separated. M minus 1 minus n minus 1 into d equal to n minus m. So this is m minus 1 minus n plus 1 d equal to n minus m. So m minus n equal to n minus 1. So d will be equal to n minus m upon m minus n. So I can write this m minus n as n minus m, taking the negative sign outside. So we can cancel this and we'll get minus 1. Okay. So d is equal to minus 1. We got the value of d, which we can substitute in our AP. Okay, minus 1. So this becomes, what about A? If you add those two terms, to A plus D we can substitute as 1. Okay. Or I'll write like this. We have got D, right? So we can substitute in any one of the equations. Suppose I'm substituting in AM. So A plus M minus 1 into D equal to N. So D is minus 1. So A will be N. This is minus 1. So minus M plus 1. So plus M minus 1. This is our A. A we have to substitute here. Okay. And this is P minus 1. So minus P plus 1. So the answer is N plus M minus P. This is your pth term. Next subtopic is arithmetic mean. Okay. So if there is two numbers, say A and B, okay, we can insert a number A in between A and B, and this is called arithmetic mean. Okay, such that it is given by A plus B by 2. That is the mean of the two numbers. So if you have a sequence, okay, then A is first term, B is the last term. So in between the numbers, that is arithmetic means, are given by A1, A2, A3 till AN. And this AN is written as A plus ND, okay, where ND, that is D, is given by B minus A upon N plus 1. Okay, so this is the formula for arithmetic mean. So there is a question, insert 6 numbers between 3 and 24 such that the resulting sequence is an AP. So we have to put 6 numbers in between 3 and 24. A1, A2, A3, A4, A5 and A6. Okay. So we have A, which is 3. Okay. Then B is 24 and N, that is you have to count the numbers. These are 6 terms, 7 and 8. Total number is 8. Okay, N is 8. So we can put in the formula AN equal to A plus N D. But we don't have D. So D we can find by using AN. Okay. AN is our 24 So A plus n minus 1, it's the term. So 7 into D. So this is 24 minus 3, 21 upon 7. So D is 3. Okay, so we got D also. Now we have to use that formula. An equal to n A plus n D. So for n equal to 1, A is 3, D is 3. So this is 6. A2, 3 plus 2, 3 is 6, 9. A3, 3 plus 9, 12. A4, 12, 15. A5, oh, this is capital A. And A6 is 21. Okay, so these are the 6 numbers. So the next subtopic is geometric progression, which is GP. Okay, so here the terms, that is sequence, is given by A1, A2, A3, AN, and so on. It is called a geometric progression if, okay, there is a ratio of AK plus 1 upon AK, which is R. Okay, this is called a common ratio for K greater than or equal to 1. That is, we have to take the ratio of the terms, that is A2 upon A1. Okay. Yeah. So this is called a common ratio. Like we had in AP, common difference. Here we have a common ratio. So that should be same. Okay. First, so the sequence is given by A into R, A into R square. Okay. And so this is the first term. Okay. And the general term is given as an equal to ar n minus 1. Ar raised to n minus 1. This is the nth term of a GP. Okay. Series, that is the sum of the terms in GP, is given by Sn equal to a 1 minus r raised to n upon 1 minus r, or we can write Sn a into r raised to n minus 1 upon r minus 1. Okay, so these are the two formulas. That is, this is or any one of this you can use. Okay, let's see some examples. So the difference between AP and GP is the common difference and common ratio. Okay. Example is you have to find the 10th and nth terms of the GP. So the sequence is given. Okay. So A is 5, R is 25 upon 5, which is 5 again. So you have to find the 10th term. So A10. This is given by A R raised to 10 minus 1. So this is A is 5, R is also 5, 5 raised to 9. So using laws of indices you'll get, or exponents, 5 raised to 10. Okay. For an, it is a r raised to n minus 1. A is there and also r is there. N minus 1 and this is 1. So 1 and minus 1 gets cancelled and you get 5 raised to n. This is the an. That is the last term. Okay.